क्या आप लोग मुझे बताएंगे आप लोग लास्ट लेक्चर में क्या डिस्कस कर रहे, कौन सा टॉपिक डिस्कस कर रहे थे, कौन सा चैप्टर डिस्कस कर रहे थे? एनीवन लेट मी नो। लेक्चर तो मोस्ट प्रोबेबली हमारा पूरा रिवीजन में चला जाएगा कि क्या डिस्कस किया हमने। काफी सारे बच्चे होंगे जिनका शायद लिंक ब्रेक हो चुका है हमारा इन बिटवीन, और मे बी वी वोंट बी एबल टू टेक ओवर द चैप्टर दैट वी हैव लेफ्ट इन लास्ट लेक्चर, ठीक है? सो इट्स ओके, वी गो अकॉर्डिंगली. One second, big learner, it's very interesting chapter from physical chemistry. That is, you can say nuclear chemistry, nuclear and radiochemistry. That is the chapter what we are discussing, and it's a very potential field. Nuclear chemistry is a very important potential field, and it's a future of world even, because everyone or world is facing the scarcity of the energy, and we are searching for alternative sources of energy. Because whatever the energy we obtain as of now, that is right from the fossil fuels and petroleum products, we know very well. So these are the main sources of energy as of now, which we are using for development, for machinery and everything. We have to search for alternative energy. So amongst that, solar energy is one of the type, one of the alternative source. Tide energy is one of the source. Then wind energy is one of the source, as well as nuclear energy is also one of the alternative source for the energy. And that's why in developed countries, or many scientists are trying to develop this nuclear energy. They are trying to find out, they are going to R&D, that is research and development in nuclear chemistry, because it can be an alternative source for energy. And that's why, in that sense, this chapter is very important, that is nuclear and radiochemistry. So we have to understand the basic fundamental principles here in the chapter related with the nuclear chemistry. Now, in order to enter into the nuclear chemistry, we must know the structure of atoms. जो हमने already last lecture में discuss किया था, हम जानते हैं अच्छी तरह, because one of the chapter in 11th standard we have discussed, that is related with you can say structure of an atom. Vaishnavi, please mute your sound. Vaishnavi Bore, please. आपका sound mute कीजिए आप. Vaishnavi Bore, are you getting me?
Yes.
Yes, please mute your sound.
Yes, sir.
Yes, thank you. So accordingly, we can say here in the chapter we have to discuss the fundamental concepts, principles related with this nuclear chemistry. So in order to get that, we need to know the structure of an atom, because we have seen once we started with the chemistry, we know very well we studied the matter, and matter is anything which occupies space and has the mass is called as matter. Without matter, chemistry can't go ahead, and every matter is made up of very tiny particles known as an atom. In the 18th century, Dalton and scientists put forth the theory of the structure of atom, concept of atom, and furthermore, many scientists try to find out the structure of atom. And we, as of now, we know very well. Everyone amongst us knows very well structure of atom. That is, we can have here atom consists centrally situated highly dense nucleus, whereas electrons revolves in a circular orbits or the circular paths around the nucleus. So that is what we can say. So this is the nucleus. So this is the structure of atom. Already we have seen in last lecture. In last lecture, so this is the structure. Just a minute. So now, this is nothing but the nucleus. This is nothing but the nucleus. And nucleus consists of protons and nucleus consists of neutrons. Whereas here are the electrons. These are nothing but the electrons. Electrons so we can have protons, neutrons, and electrons are nothing but the fundamental particles of an atom. Okay. अभी हो सकता है कि तुम में से कुछ लोगों को ये ऑलरेडी सबको पता है, थोड़ा सा बोर होता होगा, हो सकता है, लेकिन मुझे लगता है ऑलमोस्ट 10 to 8 days के बाद हम लोग लेक्चर टेक ओवर कर रहे हैं. ये चैप्टर टॉपिक शायद कनेक्ट करना जरूरी है. That's why I'm taking the revision. So just try to refresh your knowledge with this revision. So this is the structure of atom. Atom consists centrally situated highly dense area known as nucleus, and nucleus consists of protons and neutrons, whereas electrons revolves around the nucleus in particular orbits or paths, and these are called orbitals. So that's why electrons. So fundamental particles of atom are nothing but protons, neutrons, and electrons, of which this atom is made up of. This is the structure of atom. Now this is the nucleus and this is the outer part. Once or whenever we decided to go with nuclear chemistry is dealing with only nucleus. It's not dealing with this outer part of the structure of an atom. So till date, no one had seen the atom. See, because this is the atom, structure of atom. Till date, there isn't any microscope, there isn't any device, electronic device, with which we can see the structure of an atom, see the atom. with the many experiments and all, scientists derive this is the structure of atom, and it has been proved by different theories, no doubt. So being atom is very small entity. It's very tiny particle. No one it has seen. No one till that has seen this atom, but its structure has been proved. And this atom has the nucleus, which is a very small part as compared with the total structure of atom. It's very small part that is having almost diameter of 10 to minus 13 meter. So 10 to minus 15 meter diameter. It's very small part called as a nucleus. And this chapter, nuclear and radiochemistry, is dealing with this nucleus. So here in the chapter, we have to enter into the nucleus of an atom. We are not relating with the outer part of an atom. So this is a very important part, what we discuss here. So this is the structure of atom, which can be made analogy, can be compared with our solar system. As in solar system, centrally we have your sun. All other planets revolve around the sun. That is the structure of solar system. Same like that. This is the nucleus in which around which electrons revolve. So this structure can be made analogy with our solar system. But here in the chapter, we have to enter into the nucleus. We are not dealing with outer part of the nucleus or other part of the structure of an atom and all. Clear with this? This is. Now, more correctly, more exactly, in nuclear chemistry, we are dealing with only nucleus, and that's why more correctly it is called as a nuclide. So this is called as a nuclide. तो उसे nuclide कहा जाता है. जैसे हम लोग नॉर्मल केमिस्ट्री में हम एटम कहते हैं, जैसे कि जिंक एटम है, सोडियम एटम है, हाइड्रोजन एटम है, ऐसा कहते हैं हम लोग. वैसा न्यूक्लियर केमिस्ट्री में we are dealing with a nucleus, and so nucleus of any of the particular atom is called as a nuclide. उसे nuclide कह के माना जाता है, जाना जाता है, हम अच्छी तरह जानते हैं. And this nuclide is denoted by X. X is equal to Z, A, and M. Okay, ये हम अच्छी तरह जानते हैं. And this A is nothing but the mass number. A is nothing but mass number. Okay, what is Z? Z is nothing but the atomic number. And what is N? N nothing but the neutron number. So be clear here. And X is the symbol of element. So मैं इसे हटा देता हूँ. So X is nothing but the symbol of element. X is symbol of element. So this is what we can say. So in the same way, you can say carbon 12, 6, 6. This is the notification for carbon. This is, you can say, nucleus of the carbon. Nitrogen 7, 14. Here again 14 I guess, 6 I guess, whatever is that. So उसी तरीके से helium आ सकता है, helium 2, 4 इस तरीके से आ जाता है. So this is the way how the nuclides are denoted. This is the general representation. These are the particular examples of these nuclides. So in nuclear chemistry, when we have to say an atom, that has to be a nuclide. That has to be called as a nuclide. And nuclide is denoted in this one. X is nothing but the symbol of element. Z is nothing but the atomic number of that particular nuclide. A is nothing but the mass number. N is nothing but the neutron number. That is what we can say. Or इसके अंदर एक फॉर्मूला भी लिख चुके हैं हम लोग. That is A is equal to Z plus M. This is nothing but the atomic mass number. This formula is also we have discussed. ये फॉर्मूला हमने स्ट्रक्चर ऑफ एटम में भी डिस्कस किया था और यहाँ पर भी आता है और इसके ऊपर न्यूमेरिकल भी आता है एग्जाम, याद रखिएगा. Where A is nothing but the atomic mass number, or it is nothing but the sum total of number of protons and number of neutrons. So this is nothing but the mass number. So if we know any two quantities, third quantity can be calculated. ये दो क्वांटिटी पता है तो ये निकाल सकते हैं, ये दो क्वांटिटी पता है तो ये निकाल सकते हैं. So this is what we have seen in last lecture. That is also called as atomic mass number, that is nuclides and all. Clear with this? ये हमने उसके अंदर डिस्कस किया. Now bit going ahead, हम अच्छी तरह जानते हैं कि these are the nuclides. They are again classified into different categories. These nuclides are classified into different categories. So we can say nuclides. Okay. So nuclides का classification जो पहला होता है, that is nothing but on based on protons and neutrons. So this is the classification of protons and neutrons, जिसके अंदर हम लोग कहते हैं there is isotopes, दूसरा isobars, तीसरा mirror nuclei, fourth, that is you can say isomers, and fifth is nothing but you can say isotones. This is again classification of nuclides. So we are discussing classification. Yeah, हमने already discussed किया है. मतलब this is the classification of nuclides. So classification of nuclides are classified on the basis of protons and neutrons. So we have isotopes, isobars, mirror nuclei, isomers and isotones. ये एक classification. दूसरा जो classification है, this classification is nothing but based on stability. तो stability के आधार पर देखते हैं हम लोग यहाँ पे दो मिलते हैं. Number one, that is unstable nuclide, and दूसरा stable nuclide. Stable. ये दो लोग हम लोग मिलते हैं. मतलब ये जो न्यूक्लाइड्स होते हैं किसी भी atom का nuclide that can be classified on based on the proton neutrons or also based on the stability like this one, that is unstable and stable nuclides like this one. इसके आधार पर classify किया जाता है। अब ये सारे definition जानते हैं, शायद तुम में से कोई जानता है तो बोलो मुझे। I would like to hear definitions from your side. Anyone knows definition of isotopes, isobars? Any one of these definitions? So anyone, please unmute your sound and let me know.
Sir, isotopes are the nuclides which have same number of protons but different number of neutrons.
Very good. What about isobars?
Sir, isobars have same. Sir, they differ in either proton or neutron. Isobars.
Yeah, but definition is a bit different. We can say isobars are the atoms of the same element having same atomic number, same mass number, but different atomic numbers. Mass number has to be similar for the isobars. Okay, here. What about this one?
Sir, mirror nuclei have different protons and neutrons, but they differ by only one. Means they have either one proton extra or one neutron extra.
Very good. Very good. These are the nuclides which just differ by one proton or one neutron. So एक का ही difference होता है, and that is either maybe proton or either maybe neutron. These are called as mirror nuclei. What about isomers?
Sir, isomers differ in their energy state levels.
Very good. Isomers are the atoms of the element having same atomic number, same mass number, same neutron number. Everything is similar. Just the energy state is different. Energy state is different. So the nuclear having higher energy state is called as a metastable state, and having lower is normal nuclear cancer. Very good. Isotones.
Sir, isotones are reciprocal of isotopes. They have different number of neutrons and same number of protons.
Very good. They differ by just neutrons, and those are called as, you can say, isotopes over here. Some of the neutron numbers, neutron number is similar. Sorry, neutron number is similar. Are different, and that's what they are called as isotones. Many examples we have seen in last lecture. But okay, very good. Next is nothing but unstable nuclides. अभी इसका ज़्यादा definition ऐसा कुछ है नहीं, but उसका एक concept है. What are the unstable and what are the stable nuclides? So the nuclide which do not changes for keeping a long time are called as stable nuclides, and nuclide which changes after keeping a long time or after some time, these are called as unstable nuclides. Undergoes decay. Unstable मतलब undergoes decay. मतलब these are radioactive elements. हम जानते हैं periodic table के अंदर हमारे जो elements है, उसमें से कुछ elements naturally radioactive elements है, और कुछ stable elements है. तो natural radioactive elements से radium, which has been first derived by Marie Curie, and she died because of the cancer due to the exposure to the radiations and all. But she has given the first radio element, that is radium. She isolated that. So that's why she is also known as father of radioactivity, even with the Henry Becquerel. No doubt. And she received the Nobel Prize for the same. She received the Nobel Prize for the same. That is what we can say. So this is what we can. So stability and instability related with radioactivity or non-radioactivity. Similarly, हम कह सकते हैं कि these stable elements मतलब non-radioactive, and these elements मतलब radioactive, because these are the nuclides which get changes. Suppose radium element है, radium धीरे-धीरे change होके finally वो lead में आ जाता है. Neptunium नाम का element वो lead में आ जाता है. तो finally unstable element जो lead में आ जाते हैं वहाँ पे stable बन जाते हैं. और ये तो पहले से stable है, मतलब जो है वैसे रहेंगे, and that's why they are called as stable. Now इसके अंदर ये भी देखा हमने कि the stability depends upon some of the factors. Few factors the stability depends upon. Stability जो है कि कौन से factor के ऊपर depend करती है. Number one, that is you can say here odd, even odd number. You can say even or odd number of protons and neutrons. तो किसी भी nuclide के अंदर proton neutron का status क्या है? Even protons, even neutrons ऐसा हो सकता है. Even protons, odd neutrons ऐसा हो सकता है. या फिर odd protons, even neutrons ऐसा हो सकता है, या दोनों odd हो सकते हैं. These are the possibilities. So even odd number of protons and neutrons present in the nuclide of an atom, that makes difference while we have this stability is concerned. Number one. Number two is nothing but proton to neutron to proton ratio. Yeah, proton to neutron ratio. Neutron to proton ratio. This is also one of the important factor. Neutron to proton ratio. When it is carefully studied, told that data is carefully studied, found that the elements having neutron to proton ratio is equal to 1 are most stablest element. Naturally, what we got here, and those are having less than that or more than that, those are unstable in the nature. So that is what we can see here. So neutron to proton ratio also makes big difference while the stability is concerned. Number three is nothing but you can say magic number is one of the concepts. Magic number. Magic number. There are some numbers that is 2, 20, 50. 84. Like these are the numbers which scientists got. So the atoms or nuclides having this type of mass number or this type of atomic number are found to be stable in the nature. And that's why these numbers are called as stable magic numbers, because of these numbers, they gives the stability to that nuclide. They impart stability to that nuclide. So that's why these magic numbers. There are certainly many reasons behind the stability of the nucleus, but these are a few superficial what we got here. So magic number like this one, this is one of the concepts. Number 4 is nothing but you can say nuclear potential. Nuclear potential. Nuclear potential is also one of the important concepts. What is this nuclear potential? This is reason for the stability of nuclei. अभी देखिए न्यूक्लियर पोटेंशियल होता है कि हमने स्ट्रक्चर ऑफ एटम डिस्कस किया कि दिस इज न्यूक्लियस वेयर प्रोटॉन न्यूट्रॉन्स इलेक्ट्रॉन एग्जिस्ट होते हैं और यहाँ पे इलेक्ट्रॉन्स रिवॉल्व होते हैं, यहाँ पे इलेक्ट्रॉन्स रिवॉल्व होते हैं. अभी जनरल केमिस्ट्री के कुछ कॉन्सेप्ट्स है जो हमारे लिए बहुत यूजफुल होता है. जैसे कि यहाँ पे हम देखते हैं कि these are the electrons. Okay, electrons revolves in circular orbit और this one यहाँ पे हम देखते हैं. और here are the protons and neutrons ये न्यूक्लियस के अंदर. अभी हमें अच्छे तरह जानते हैं कि इस चैप्टर के अंदर हम कंसर्न है नहीं है आउटर पार्ट के साथ, हम सिर्फ न्यूक्लियस के पास और न्यूक्लियस के साथ ही कंसर्न है. अभी इस न्यूक्लियस के अंदर कई सारे पार्टिकल है, मोर देन 40-70 पार्टिकल्स हैज बीन डिस्कवर्ड व्हिच आर प्रेजेंट इन द न्यूक्लियस. बट हम अगर सुपरफिशियल लेवल पे भी डिस्कस करते हैं तो हम जानते हैं कि इलेक्ट्रॉन्स, प्रोटॉन्स, न्यूट्रॉन्स आर प्रेजेंट. तो इसके अंदर प्रोटॉन्स एंड न्यूट्रॉन्स दो तो प्रेजेंट है ही है, प्रोटॉन्स एंड न्यूट्रॉन्स दो प्रेजेंट है. उसके अलावा भी बाकी सारे पार्टिकल, मेसॉन्स, पायन्स, ग्लॉन्स, क्वार्क्स, एंटीन्यूट्रॉन, एंटीप्रोटॉन, काफी सारे पार्टिकल्स हैं, मोर देन 40 प्लस पार्टिकल्स न्यूक्लियस के अंदर मिले हैं. बट ये दो पार्टिकल मेन है, प्रोटॉन्स, न्यूट्रॉन, जो न्यूक्लियस के अंदर प्रेजेंट. नाउ थिंग इज दैट unless and until these particles are held together in a nucleus, it's simply impossible to have the existence of the nucleus. Nucleus exist नहीं हो सकता. जिस तरीके से एटम के अंदर protons and electrons are held together due to electrostatic force of attraction. हम जानते हैं जनरल केमिस्ट्री का कॉन्सेप्ट है, इलेक्ट्रोस्टैटिक का कॉन्सेप्ट है. Like charges has the repulsion and opposite charges has the attraction. Proton being positively charged and electron being negatively charged, they have attraction for each other. And that's why atom as a whole exists. Atom as a whole exists. तो एटम एग्जिस्ट इसी कारण से होता है. प्रोटॉन बीइंग पॉजिटिव हैज अट्रैक्शन फॉर इलेक्ट्रॉन बीइंग नेगेटिव. बट व्हेन वी डिस्कस अबाउट द न्यूक्लियस, प्रोटॉन इज पॉजिटिव चार्ज, न्यूट्रॉन इज न्यूट्रल. न्यूट्रॉन के ऊपर कोई चार्ज नहीं है, प्रोटॉन के ऊपर चार्ज है पॉजिटिव. हाउ these particles are held together? They are held, and that's why nucleus exists. कौन से forces है? So scientists try to find out these forces which are present behind this one, and the energy required to bind this particle together is nothing but the nuclear potential. Is nothing but the nuclear potential. So nuclear potential is this: how much energy is released when these particles comes together. That is nothing but the nuclear potential, and that is measured in binding energy. You can say binding energy. The amount of energy required to bind this particle together in the nucleus is nothing but the binding energy. या फिर उसको opposite में भी ले सकते हैं. अगर ये nucleus हमें break करना है, तो energy has to be supplied. किसी भी न्यूक्लाइड का न्यूक्लियस अगर ब्रेक करना है तो एनर्जी हैज टू बी सप्लाइड. सो द अमाउंट ऑफ एनर्जी रिक्वायर्ड टू ब्रेक द न्यूक्लाइड इनटू न्यूक्लियॉन्स, न्यूक्लियॉन्स को अलग-अलग करना है, उसके लिए जो एनर्जी सप्लाई करना पड़ेगा, दैट इज नथिंग बट आल्सो बाइंडिंग एनर्जी, एंड दैट इज नथिंग बट द पार्ट ऑफ न्यूक्लियर पोटेंशियल. सो देयर आर मेनी फोर्सेस. देयर इज अट्रैक्शन फोर्स बिटवीन प्रोटॉन प्रोटॉन, प्रोटॉन न्यूट्रॉन, न्यूट्रॉन न्यूट्रॉन, एंड overall there are some repulsive forces, there are some attractive forces, but when nucleus exists, that means attractive forces exceeds the repulsive forces, and that's why nucleus exists. Otherwise it was simply impossible to exist the nucleus. So in that sense we can say these particles are held together because of attractive force exceeds the repulsive forces, and that's why nucleus exists, and that is a part of nuclear potential and nothing but the binding energy. So this binding energy is given by you can say binding energy का जो फॉर्मूला देखा है, that is delta m into 931 million electron volt. ये फॉर्मूला बनाता है बाइंडिंग एनर्जी का. So binding energy is nothing but the product of delta m into 931. So actually E is equal to mc square नाम का जो फॉर्मूला दिया है हम लोगों को आइंस्टाइन ने, उस फॉर्मूले के आधार पर ये डिराइव होता है. आइंस्टाइन का जो फॉर्मूला E is equal to mc square, that is mainly applied to the nucleus, and that actually evolved from the nuclear activities or phenomena, no doubt at all, while he was studying that. So in that sense, you can say binding energy is the formula which is derived again from the same formula. Binding energy is nothing but the delta m into 931, or जो basic formula है, that is E is equal to mc square, which is called as Einstein's equation. E is equal to mc square. E stands for energy, M stands for mass and C stands for velocity of light. और हम अच्छी तरह जानते हैं velocity of light कितना है, ये है. So अगर हमें एनर्जी कैलकुलेट करना है तो मास एंड वेलोसिटी ऑफ लाइट पुट करना पड़ता है. ये हमने यहाँ पे पुट किया है. दैट इज नथिंग बट द बाइंडिंग एनर्जी. Mass is nothing but the delta M, and this energy is converted into million electron volt. That is 931. And this delta M is nothing but the mass defect. B binding energy. Delta M mass defect. And 931 comes from this velocity of light, which is converted into million electron volt, because this binding energy is represented into million electron volt. So this is nothing but the mass defect, delta M. अब ये mass defect क्या है? अगर आप mass defect की बात करते हैं, so उसके लिए छोटा सा फॉर्मूला आता है वापस. What is this mass defect? So mass defect delta M is equal to M dash minus M. So that is what we can say here. M dash minus M. So this is nothing but the mass defect formula. So delta M is nothing but the mass defect. M is nothing but the M dash is the calculated mass, and this is nothing but the observed mass. अभी calculated mass और observed mass क्या आता है? देखिए कि अगर हम कार्बन की बात करते हैं, कार्बन 6 and 12 इसकी बात करते हैं, इसके दो मास होते हैं. एक है that is calculated mass और दूसरा that is you can say observed mass. Means इसका मतलब क्या है कि कार्बन 12 की बात करते हैं तो उसके अंदर 12 पार्टिकल्स हैं, जिन्हें हम लोग न्यूक्लियस कह सकते हैं. 12 पार्टिकल्स हैं. तो ये 12 पार्टिकल्स, एक पार्टिकल का भी इसके अंदर देखेंगे तो कार्बन 12 6, मतलब इसके अंदर प्रोटॉन्स कितने हैं 6, न्यूट्रॉन्स कितने हैं 6, और टोटल ए कितना है 12. सो एक प्रोटॉन का जो मास होता है वो मल्टीप्लाई बाय 6 प्रोटॉन्स, एक न्यूट्रॉन का मास मल्टीप्लाई बाय 6 न्यूट्रॉन्स, और कुल मिला के जो आएगा दैट इज नथिंग बट द मास नंबर. ये यहाँ पे आएगा, दैट इज कैलकुलेटेड मास. तो हर पार्टिकल का मास इंडिविजुअली पुट करके टोटल पार्टिकल्स मल्टीप्लाई बाय दैट मास इज नथिंग बट द कैलकुलेटेड मास. एंड व्हेन these particles came together, held together, nuclide is formed. At that time this is called observed mass. तो न्यूक्लाइड जब तैयार होता है some mass is lost, some mass is lost. तो कैलकुलेटेड मास ज्यादा है, ऑब्जर्व मास कम होता है, और दोनों का जो डिफरेंस है दैट इज नथिंग बट द डेल्टा. दिस मास इज लॉस्ट. अलग अलग पार्टिकल लेंगे तो उनका मास ज्यादा आता है, और सारे पार्टिकल जब इकट्ठा के न्यूक्लाइड बनता है तो उसका मास कम आता है. तो where that mass has lost, that was the basic question asked by the Einstein and scientists, and they comes to that there is some mass which is lost, and that is nothing but the mass defect. So एक बेसिक क्वेश्चन आ जाता है कि कई बार वो पूछा गया नहीं, सम बेसिक कॉन्सेप्ट्स के अंदर भी मैंने बताया था कि सम बेसिक कॉन्सेप्ट्स के अंदर हमारे पास एक लॉ आता है, दैट इज लॉज ऑफ केमिकल कॉम्बिनेशंस के अंदर लॉ ऑफ कंजर्वेशन ऑफ मास, बराबर है. सो लॉ ऑफ कंजर्वेशन ऑफ एनर्जी यही है, इसी के कारण आया, नो डाउट. बट लॉ ऑफ कंजर्वेशन ऑफ मास नाम का कॉन्सेप्ट हमें सम बेसिक कॉन्सेप्ट्स इन केमिस्ट्री के अंदर डिस्कस किया था. तो अकॉर्डिंग टू दैट क्या है, मास इज नाइदर क्रिएटेड नॉर डिस्ट्रॉयड ड्यूरिंग द कोर्स ऑफ केमिकल रिएक्शन, ऐसा वो स्टेट करता है. बट वो पार्टली ट्रू है, 100% ट्रू नहीं है, और हमने ये दुर्भाग्य से हमें एग्जाम के अंदर लिखना पड़ता है. अकॉर्डिंग टू दिस लॉ, मास इज नाइदर क्रिएटेड नॉर डिस्ट्रॉयड ड्यूरिंग द कोर्स ऑफ केमिकल रिएक्शन. बट एक्चुअली Einstein is the scientist who proved that mass is not conserved, mass is not maintained same during the course of chemical reaction, because there are some of the reactions which are exothermic, in which heat is released. There are some reactions which are endothermic, in which heat is absorbed. आइंस्टाइन के सामने सवाल था कि जो रिएक्शन एक्सोथर्मिक है उसमें हीट कहां से आता है, और जो रिएक्शन एंडोथर्मिक है उसके अंदर हीट कहां जाता है, जो एब्जॉर्ब किया हीट जाता कहां है. And that was the question. He tried to find out answer for this one, and he found the answer in the mass defect. Exothermic reaction in which heat is released, that is due to mass lost. When particles held together, some mass is lost, and that mass is converted into energy. E is equal to mc square. Mass is converted into energy. This is the equation. That's why Einstein derived this equation, E is equal to mc square. In exothermic reaction, there should be some mass lost, and that's why energy is released. Or whenever energy is absorbed, that should be converted into mass, so mass should increase. तो ये कॉन्सेप्ट करनी आता है. तो सब में से कॉन्सेप्ट के अंदर हमने जो कहता है लॉ ऑफ कंजर्वेशन ऑफ मास, वो पार्शियली ट्रू है, 100% ट्रू नहीं है. और व्हेन आइंस्टाइन प्रूव्ड दिस इक्वेशन, at that time it was a drawback of that law, no doubt at all. But still this Einstein equation is mainly applied to the nuclear reactions or nuclides mainly. So ये बाहर इतना ज्यादा पार्टिकल के बाहर, न्यूक्लियस के बाहर उतना ज्यादा अप्लाई नहीं किया जाता जितना कि वो न्यूक्लियस के लिए अप्लाई किया जाता है. So its main applications are here into the nucleus or nuclei, you can say. So nuclear activities. So this is what we can say mass defect law. So ये हमने उसके अंदर लास्ट लेक्चर के अंदर डिस्कस किया था. इसके अंदर ये भी डिस्कस किया था हमने बाइंडिंग एनर्जी पर न्यूक्लियर. बाइंडिंग एनर्जी पर न्यूक्लियर में बाइंडिंग एनर्जी निकाला हमने, पर न्यूक्लियर निकालना तो हम ये भी फॉर्मूला देखा कि बाइंडिंग एनर्जी पर न्यूक्लियर इज इक्वल टू बार इज इक्वल टू बी upon A, that is you can say. So binding energy upon E. So this is binding energy per nucleon. BE bar, देखिए BE, ये BE और BE bar. So BE is representing the binding energy, overall binding energy, and BE bar indicating the binding energy per nucleon. Because BE upon A करेंगे तो per nucleon. तो जैसे कि यहाँ पे 12 particles है, 12 यहाँ पे रखता है, तो हम लोग निकाल सकते हैं कि हर पार्टिकल के लिए बाइंडिंग एनर्जी कितना है, क्योंकि दो प्रोटॉन्स अलग है, न्यूट्रॉन्स अलग है, सबका थोड़ा बहुत अलग हो सकता है, बट ऑन एन एवरेज बाइंडिंग एनर्जी यहाँ पे निकाला जा सकता है पर पार्टिकल. सो बाइंडिंग एनर्जी पर न्यूक्लियन निकाला जाता है लाइक दिस वन, ये फॉर्मूला. तो ये इतने फॉर्मूला हम देखते थे कि व्हाट इज बाइंडिंग एनर्जी, व्हाट इज आइंस्टाइन इक्वेशन, व्हाट इज मास डिफेक्ट, हाउ टू कैलकुलेट मास डिफेक्ट, and what is this binding energy per nucleon, and this binding energy per nucleon also affects the stability of the nuclei. तो बाइंडिंग एनर्जी पर न्यूक्लियन का भी एक ग्राफ मिलता है जो हमने देखा था लास्ट टाइम कि किसका बाइंडिंग एनर्जी 7 बिलियन इलेक्ट्रॉन वोल्ट से नीचे है, किसका 7 से ज्यादा है. The stablest element or stablest nuclide on this earth has the binding energy between 7 to 9 billion electron volt के बीच में है, और the elements having 7 billion electron volt energy below 7 they are unstable in the nature. तो जो रेडियोएक्टिव एलिमेंट है वो उनका बाइंडिंग एनर्जी 7 से कम है, and that's why they are unstable in the nature. Lighter elements, they have their binding energy less than the 7, but though they are very stable in nature because their stability is not only related with binding energy but with some other factors like proton to neutron ratio, nuclide and all. There are many factors responding for that, but in general you can apply this theory, that is you can say binding energy. तो ये हमने इस चैप्टर के फर्स्ट हाफ में यहाँ पे इसके बारे में डिस्कस किया था. क्लियर है? इसके बाद हम लोग शिफ्ट ऑन किए थे, मूव ऑन किए थे, दैट इज रेडियो एक्टिविटी के लिए. सो रेडियो एक्टिविटी इज वन ऑफ द इंपॉर्टेंट फिनोमेना जिसके लिए हमने शिफ्ट ऑन किया था उसके अंदर. ठीक है ना? सो लेट्स मूव टू रेडियो एक्टिविटी. ओके, सो then first of the chapter is related till up to the binding energy per nucleon वगैरह वहां पे हम डिस्कस करते हैं. उसके बाद जो हम लोग आए थे, that is nothing but the radioactivity is very important part, that is the second section of this chapter. इस चैप्टर के 3 सेक्शन अगर हम करते हैं, पहला सेक्शन विद फंडामेंटल प्रिंसिपल्स ऑफ दिस न्यूक्लियर केमिस्ट्री, second part is related with this radiochemistry, and third part is related with the applied part of principles of nuclear chemistry and radioactivity. So radioactivity is the second part. अभी ये radioactivity होता क्या है, हमने इसके बारे में डिस्कस किया कि there are two nuclides, दो nuclides होते हैं, that is you can say stable nuclides and you can say unstable nuclide. Okay. अभी जो unstable nuclide, these are called radioactive. These are called radioactive because these are the elements which emits the radiations spontaneously and continuously. Suppose ये हमारा nucleus है, atom का structure है, और यहाँ से emissions आते हैं, continuous and spontaneous emissions आते हैं. So this is the nuclide. This is the nuclide which emits spontaneously this alpha, beta, or maybe gamma radiations. So these particles, these are called the nuclear particles. Actually, gamma is not a particle. Gamma is an energy radiation actually. But alpha, beta are the particles, and this is the energy. You can say radiation. So in that sense, unstability is related with nothing but the radioactivity. Radioactivity is the phenomena. It is the process in which one unstable nuclide gets converted to stable nuclide by emitting some nuclear particles and energy. And this is a very spontaneous process. This is very continuous process and naturally occurring. And that's why this is called radioactivity. Henry Becquerel is the scientist. Who discovered this phenomena, that is radioactivity. And Marie Curie is the second scientist who isolated first radioactive element, that is radium. So that is what we can say. So both scientists have a very in-depth contribution, or very extensive contribution here in the field of this radioactivity. So that is what we can say radioactivity. So radioactivity is the phenomena. It is the process in which unstable nuclide or any of the nuclide emits spontaneously and continuously some nuclear particles and energy, and gets converted into stable nuclide. That process is called the radioactivity. This radioactivity phenomena is also known as decay. This phenomena is also known as decay. So decay bhi kaha jata hai. This process is also called as a decay. And next, what we say, decay is the process of continuous and spontaneous emission of high energy radiations and nuclear particles from the nucleus of an atom. और ये जो particle और energy बाहर आता है वो nucleus से आता है, जिसका बाहर ही इससे कोई लेना देना नहीं है. Even This radioactivity or decay is independent of temperature, pressure, and state of the substance, chemical state of the substance. मतलब all these doesn't depend upon the state. जैसे कि रेडियम नाम का एलिमेंट है, रेडियम नाम का एलिमेंट अगर गैसियस स्टेट में होगा, लिक्विड स्टेट में होगा, सॉलिड फेज में होगा, that doesn't matter. That will emit the radiation. That will emit the radiations even in solid state, even in liquid state, even in gaseous phase. Even that doesn't, temperature doesn't make any difference, state doesn't make any difference, your pressure doesn't make any difference on this radioactivity or decay. So decay and all are independent of temperature, pressure, and state of the substances. Then we are seeing what is this rate of decay. Rate of decay क्या होता है ये भी हमने देखा उसके अंदर. So rate of decay is nothing but you can say rate is directly proportional to minus dn upon dt. ऐसा देखा minus dn upon dt हमने देखा. So minus dn upon dt. So this is nothing but the rate of decay. ये भी एक important formula है जहाँ से हमारा derivation actually start होता है. So सबसे पहला phenomena है कि radioactivity नाम का phenomena है, that is also known as a decay. ये जो decay होता है, that decay is independent of temperature, pressure, and state of the substance, and this decay is measured in the rate of decay. This is also called as disintegration. Decay मतलब disintegration, breakdown होने की process है. Decay, okay? कोई भी nucleus breakdown होता है, and that is nothing but decay, and this is measured in rate of decay. Rate of decay क्या होता है? तो उसका एक definition है, number of atoms of that nuclide disintegrating in unit time. That is nothing but the rate of decay. So यहाँ पे equal to है, that is you can say rate of decay is equal to, because वो rate law है. So rate of decay is equal to dn upon dt. तो इसका डेफिनेशन ऐसा है, नंबर ऑफ रेडियोएक्टिव न्यूक्लाइड्स डिसइंटीग्रेटिंग इन यूनिट टाइम. गिवन टाइम में कितने नंबर ऑफ एटम्स डिसइंटीग्रेट होते हैं, दैट इज नथिंग द रेट ऑफ डीके. सपोज इनिशियली हमारे पास 100 एटम्स दिए हैं, 100 न्यूक्लाइड्स दिए हैं, और उसमें से 10 न्यूक्लाइड्स डीके होते हैं 1 सेकंड्स में. तो हम बोल सकते हैं 10 upon 1 second. That is nothing but the rate of decay. So rate of decay is measured in such a way, that is number of radioactive nuclides disintegrating in unit time is nothing but you can say rate of decay. And then there is you can say rate law. There is you can say rate law. Rate law okay. There is called as rate law. So rate law क्या कहता है? Rate law क्या कहता है? This number of atoms disintegrating in unit time is directly proportional to, so minus dn upon dt is directly proportional to number of atoms present at that instant. Number of atoms of nuclei present at that instant. This is called as rate law. Decay rate law. ये कहता है, देखिए ये जो हम लोग बात कर रहे हैं, that is nothing but rate of decay, and this is nothing but the rate law. तो rate law को कहना क्या है कि dn upon dt मतलब rate of decay is directly proportional to number of atoms of that radionuclide present at that instant. तो ये decay होने वाले number of atoms कितने हैं, nuclide कितने हैं, radioactive nuclide कितने वहां पे present है, वो जितने ज्यादा होंगे उतना decay का rate ज्यादा होगा, ये जितने कम होंगे उतने decay का rate कम होगा, ऐसा ये rate law कहता है. So according to this rate law, rate of decay is directly proportional to number of radioactive nuclide present at that instant. उस मोमेंट पे, उस टाइम पे कितने नंबर ऑफ एटम्स प्रेजेंट है उसके ऊपर वो डिपेंड करता है. दैट इज व्हाट वी कैन से रेट ऑफ डिके. सो इसे सॉल्व भी करते हैं, तो माइनस dn अपॉन dt इज इक्वल टू लैम्डा n. ये आ जाता है हमारे पास इक्वेशन. सो दिस इज द इक्वेशन व्हाट वी गेट हियर. सो लैम्डा इज नथिंग बट द प्रोपोर्शनलिटी कांस्टेंट, dn upon dt is nothing but the rate, and this is nothing but the number of atoms of radionuclide present at that instant. इसी को हमने, ये जो रेट लॉ है, इसी को रीअरेंज करके हमने इंटीग्रेट किया. सो इसे रीअरेंज कैसे किया हमने, तो माइनस dn अपॉन m इज इक्वल टू लैम्डा dt. दिस इज इक्वेशन नंबर 2. इसे इंटीग्रेट किया हमने, और इसे इंटीग्रेट किया, दैट इज माइनस dn अपॉन n इज इक्वल टू इंटीग्रेशन लैम्डा dt. ये माइनस इधर का यहाँ पे शिफ्ट कर दिया हमने माइनस, और इसे इंटीग्रेट किया n0 टू np, और t इज इक्वल टू 0 टू t इज इक्वल टू t. इस लिमिट में हमने इंटीग्रेट किया. मतलब ये इंटीग्रेट भी क्यों किया हमने, ये भी याद रखिएगा. रेट लॉ के अंदर क्या कहता है कि नंबर ऑफ एटम डिसइंटीग्रेटिंग, मतलब रेट ऑफ डीके इज डायरेक्टली प्रोपोर्शनल नंबर ऑफ एटम्स प्रेजेंट एट इंस्टेंट. हम सॉल्व भी करते हैं, तो कितने समय में कितने एटम डिसइंटीग्रेट होंगे ये रेट लॉ नहीं बता सकता. मतलब अगर मानो कि 5 मिनट के बाद कितने एटम डिसइंटीग्रेट होंगे, कितने बचेंगे, 10 मिनट के बाद कितने एटम डीके होंगे, कितने बचेंगे, ये इक्वेशन नहीं दे पाता है. ये सिर्फ रेट लॉ देता है. ये सिर्फ इतना कहता है कि रेट ऑफ डिके इज डायरेक्टली प्रोपोर्शनल नंबर ऑफ एटम प्रेजेंट एट दैट इंस्टेंट। स्टार्टिंग में 100 एटम थे, उसके ऊपर डायरेक्टली प्रोपोर्शनल। 5 मिनट के बाद 50 एटम है, उसके ऊपर डायरेक्टली प्रोपोर्शनल। 10 मिनट के बाद 25 एटम्स है, उसके ऊपर डायरेक्टली प्रोपोर्शनल। बट कितने मिनट में कितने एटम डिके होंगे ये इक्वेशन नहीं दे पाता, और इसीलिए इस इक्वेशन को हमें इंटीग्रेट करना पड़ता है बिटवीन द लिमिट्स। n0 is the initial amount, nt is the final amount, time t is equal to 0 जब हमारे पास n0 एटम्स है, और time t is equal to t when nt एटम्स बचते हैं। और इसे जब हम लोग सॉल्व करते हैं तो फाइनली हमने इक्वेशन दे रखा था कल, लैम्डा इज इक्वल टू 1 अपॉन t ln n0 अपॉन nt, या फिर लैम्डा इज इक्वल टू 2.303 अपॉन t log बेस 10 n0 अपॉन nt, या फिर n। ऐसे ये दो इक्वेशन हमने डिराइव किए थे। दिस इज नथिंग बट इट्स इंटीग्रेटेड रेट लॉ। दिस इक्वेशन इज नथिंग बट द इंटीग्रेटेड रेट लॉ। दिस इज जस्ट रेट लॉ एंड दिस इज नथिंग बट द इंटीग्रेटेड लॉ। अभी ये लॉ से क्या होता है देखिएगा, इस लॉ से क्या कर सकते हैं हम लोग, दिस इज द टाइम एंड दिस इज द डीके कांस्टेंट। तो अगर किसी भी न्यूक्लाइड का डीके कांस्टेंट हमें पता है, इनिशियल क्वांटिटी पता है, तो टी टाइम में कितने रिएक्ट होंगे और कितने बचेंगे, कितने डीके होंगे और कितने बचेंगे, we can calculate using this one. We can calculate using this equations. तो ये दोनों equations यूज करके हम लोग निकाल सकते हैं how much number of atoms are decayed in a given time और how much number of atoms are remaining after a time t. So this is the equation which is useful और इसी से निकाला जाता है। और ये टेक्निक जो है ना, एप्लीकेशन में आप देखेंगे कार्बन डेटिंग जैसे टेक्निक्स है और कई सारे टेक्निक्स है जिसे नेचुरल क्लॉक्स भी कहा जाता है। यही टेक्निक यूज करके हम एज ऑफ अर्थ कैलकुलेट कर पाए, एज ऑफ रॉक्स कैलकुलेट करते हैं, एज ऑफ fossils हम लोग कैलकुलेट कर सकते हैं, करते हैं। So this is only question. So in that sense, when we have started with the radioactivity, we have seen the definition of radioactivity. Furthermore, we have seen what is decay, on what factor does this depends. Next, rate of decay is nothing but number of atoms disintegrating in unit time. Then we have seen rate law. Rate law क्या कहता है कि rate is directly proportional to number of atoms present at that instant. But this equation, rate law, is not useful to calculate the number of atoms decayed in given time. So we have to go for integrated rate law. So ये rate law है और ये integrated rate law है. So by integrating this equation between the limits, that is n0 is the initial number of nuclides, radioactive nuclides at time t is equal to 0. At nt is the final amount remaining after time t is equal to t. Integrating between these limits, we can get this final equation. This is called the integrated rate law. Integrated rate law gives the relation between number of atoms disintegrated in time t. By knowing the decay constant, we can calculate this one. So this is what we can decay constant. इसे हम निकाले हैं और इसी के आधार पर हम हाफ लाइफ पीरियड निकालते हैं, उसका ग्राफिकल रिप्रेजेंटेशंस, एंड देन हम लोग decay की तरफ चलते हैं। ठीक है, बट दिस इज द रिवीजन फॉर द टॉपिक व्हाट वी हैव सीन इन लास्ट लेक्चर्स। मुझे लगता है कि आपको थोड़ा आइडिया आया होगा। मैं कल के लिए आपको सूचित करता हूँ कि थोड़ा बहुत आप भी पढ़ लीजिएगा। अगर अभी के टॉपिक में कुछ डाउट है तो कल डाउट कर लेते हैं, नहीं तो एक 10 मिनट में रिवीजन होकर हम लोग अपना नया टॉपिक शुरू कर देंगे, दैट इज मोड्स ऑफ डीके। Remember this. Till then, thank you very much. See you tomorrow. Thank you very much.